To conclude our coverage of materials, we're going to create an LCD screen, which is going to be kind of complicated, involving a couple of different maps combined in interesting ways, especially using the OSL Composite node. Let's select the LCD screen. We can actually click a couple of times in the area of the screen. Click the first time and you'll select the display glass. Click again in the same location and you'll select the display LCD object. And then isolate that selection. And let's do an Arnold rendering with focus on the perspective view. Go to Arnold Render View, and initiate an interactive production rendering. Here it is with just a neutral gray standard surface applied. Now let's open up the material editor. And here we see a partial graph. I've got a couple of noise maps I prepared in advance that will supply the pattern on the background of the LCD screen. We also have the network we created in a previous movie, which is a layer shader for the buttons. We're going to be using this vector map node in the network that we create now. So I've left that here so we can just use that same map and not have to recreate it. We won't be using the material map browser anymore, so just to save space, we can close that. We can click on the button on the material editor toolbar to hide or show that. With the display LCD object still selected, let's graph its network. From the Slate Material Editor menus, choose Material, Get From Selected. And here is the standard surface. We can move that and navigate with the middle mouse button. Bring that around and maybe zoom in with Control Alt and middle mouse button. We want to connect something to the base color. So drag out from that base color, release the mouse. From the pop-up menu, choose OSL, Compositing, Composite. Then we get another pop-up menu from which we need to choose which output to connect. Let's choose Out, which is the color output. And we don't see much change. If we change the top layer RGB, we'll see what happens here. So we've got a top layer and a bottom layer to the composite map. With that map selected, let's rename it. We'll call it LCD base color. This base color is going to be separated into basically two elements: the lettering or the graphics and the background. And to make that separation or mask, we'll use the vector map from the previous movie. Connect the vector map output to the top layer alpha of the LCD base color. Then in that composite node's parameters, we can change the bottom layer RGB. Let's bring its value down to 0. And now we see we've got a top layer which is gray and a bottom layer which is black. But it's not perfectly black, because we do have a specular component to our material. If we select that material, we'll see we have a specular roughness of 0.5 and a specular color weight of 1 with a specular color of white. I want these elements, these graphics here, to render as perfectly black so I can map this specular color. Let's make a duplicate of this LCD base color composite node. Hold down Shift and drag to make a duplicate, and that preserves the connection to the vector map. With that new composite node selected, we'll rename it. We'll call it LCD Specular Color. Connect its output to the specular color of the material, and select that OSL composite node, and we can test it. If we change the bottom layer RGB, increase that up to white, we'll see a kind of gray color in the lettering. Bring that down to black, and we see a solid black color. All right, we can also increase the top layer RGB up to white. So back to the LCD base color, or the background. I've got a couple of noise maps prepared here. Let's just see what those look like temporarily. If we connect LCD noise large to the base color of the standard surface, we'll see that I've created a noise map that's got some purple and magenta colors. If we select that map, we can see those colors here. We've also got the small noise. Connect that to the base color just temporarily. And that's a noise pattern with a smaller scale to simulate the grain of an LCD screen. Okay, let's reconnect the LCD base color to the base color of that standard surface. To combine these two noise maps, we can use an Arnold multiply node. That'll be connected to the top layer of the LCD base color node. So drag out from that top layer and choose Arnold, Math, multiply. And then connect the two noise maps to the inputs of that multiply node. And now those are combined, and we see them in the background here. That looks pretty good, but we can make this look even more realistic by varying that base color. So the areas around the edges are going to be a little bit brighter. That's going to be a more naturalistic effect. First, let's rename this new multiply node. We'll call it LCD Noise Combined. To combine two different versions of that base color, let's make a clone of this composite node. Once again, hold down Shift and drag to create a duplicate. Rearrange the graph a little bit here. We're going to use a different source for the alpha here, so let's delete this connection to the vector map. You can select that wire and press the delete key. This new composite node is going to be the LCD background. So let's rename it LCD background. And we'll take the output of the background node, connect it to the top layer RGB of the LCD base color. And so far we don't see any difference because we haven't created a mask or a variation on our noise. We'll pan over a little bit with the middle mouse button. So we need to supply something to the top layer alpha here. So once again, drag out, release the mouse. This time it's going to be a bitmap, so choose OSL, bitmap lookup. We're prompted to choose a bitmap from our current project's Scene Assets Images. We've got one in here, graphics lcd.png. That's just a gradient image. And we need to connect to something. We get a pop-up dialog. That alpha will only select a floating point input. We can't supply an RGB connection there. So let's choose luminance, which is just the brightness. In our rendering, we can see the effect of the gradient applied. The center here is a different color from the edges. We'll select that bitmap node and rename it LCD Gradient. And in this case, we want this LCD noise combined to be the bottom layer, so connect it to the bottom layer. And we can disconnect the top layer. The top layer is going to be a color-corrected version of this noise. So let's drag out from the top layer RGB, release the mouse, and choose Arnold, Color, Color Correct. And once again, let's reorganize our graph so we can see a little bit better. We want to connect the multiply node to the input of the color correct node. So now we've got the multiply node feeding the bottom layer and also feeding the color correct, which is in turn going into the top layer. We'll select that color correct node and rename it as well. We'll call it LCD Noise Adjusted. And in its parameters, let's increase the exposure by 1 stop, bring that up to a value of 1. And now we see that it's brighter around the edges. Let's also increase the saturation to 1.3. And now it's more saturated around the edges as well. All right, that is our shading network. It looks a little bit daunting, but it's not quite that complicated actually. We can make this a little bit easier to see. We can select all of the nodes and hide the unused node slots. There's a keyboard shortcut for that, which is H. Might need to press that a couple of times. And then we can reorganize the graph. Click up here on the graph to lay out all. And here's our shading network. Zooming in a little bit here. We're taking two noises, multiplying them together, color correcting it, combining it with the non-color corrected version to create this gradient. That's the background. The background is actually the top layer of this composite node. Once again, as I mentioned earlier, because the vector map is black letters on a white background. And the bottom layer, which is anywhere that the vector mask is transparent, is black. And then that is supplying the base color. We've also got another composite node here, which is just color with two flat colors masked off by that same vector map. All right, cool. So we can close our material editor and we can exit out of isolate selection mode. We see the Arnold render view update. And now we've got that LCD screen behind the glass. Complex shading network with OSL composite nodes and also Arnold nodes such as color correct and multiply.